How do I anti-differentiate trig functions? Sine and cosine are easy if we just remember their derivatives. The derivative of sine of x with respect to x is cosine x, and the derivative of negative cosine is sine. So what are their antiderivatives? Knowing this, now I know something about the antiderivatives. If the derivative of sine is cosine, then the antiderivative of cosine is sine plus c. And if the derivative of negative cosine is sine, that means the antiderivative of sine is negative cosine plus c. Well, what about tangent? What would I differentiate to get tangent of x? Yeah, I'm asking, what do I differentiate to get tangent? Or what's the antiderivative of tangent? Well, I'm claiming that the antiderivative of tangent is log secant x plus some constant. How do I know this? Well, to verify this is true, it's enough to do a differentiation problem. I need to check that the derivative of log of secant of x is equal to tangent x. And how do I know this? Well, I have to differentiate this composition of functions, the composition of log and secant, which I'll do with the chain rule. Right? So what's the derivative of log? It's 1 over. So it's 1 over the inside function times the derivative of secant. What's the derivative of secant? It's secant tangent. Right? So this is 1 over secant times secant x times tangent x. Now, good news, the secants cancel, and what I'm left with is just tangent x. So I've found an antiderivative for tangent. But it's totally opaque as to how somebody would ever have gotten that as the antiderivative of tangent. And yet, once that candidate antiderivative was revealed to us, we can verify that it's truly an antiderivative just by differentiating it and checking that it really gives us tangent. Okay, let's try another one of these kinds of problems. What's an antiderivative of secant? So I'm asking for a function whose derivative is secant x, right? I'm looking for the antiderivative of secant x, right? What is that? Well, it turns out that the antiderivative of secant x is this. It's log the absolute value of secant x plus tangent x. Now again, it's totally mysterious, right, where this came from, but we can verify that that's truly an antiderivative. So to verify that the antiderivative of secant x is this, it's enough to differentiate this and end up with secant x. So let's try that. Right? I'll differentiate log of the absolute value of secant x plus tangent x, and what do I get? Well, the derivative of log is 1 over the inside function, which is secant x plus tangent x, times the derivative of the inside function. This is really the chain rule in action. Alright, now what's the derivative of this sum? Well, that's the sum of derivatives, right? So the derivative of secant is secant x tangent x, and the derivative of tangent is secant squared. And this is divided by secant x plus tangent x. Now note, I can factor out a secant x here, and I've got secant x times the numerator is tangent s plus secant x. The denominator is the same thing. I mean, I wrote it in the opposite order. But now this is great, right? This cancels, and what I'm left with is secant x. So yeah, the derivative of this is secant x, and consequently, the antiderivative of secant x is this. This is really akin to anti-multiplying, to factoring. So remember our experience multiplying and anti-multiplying or factoring numbers, right? Factoring was hard. I had to do a bunch of trial division to figure out how to factor a number. But once I had that factorization or purported factorization in hand, then checking it was easy, right? Multiplying is something that you can do. It's the same story here with derivatives, right? Anti-differentiating is hard. I mean, it seems hard to figure out what the antiderivative is. But once you show me a guess, I can verify that your guess is correct by doing the easy step of just differentiating and seeing if you're right. I hope that these examples are giving you some real respect for the true difficulties of anti-differentiation. Right? Differentiating is a mechanical process. You just have to apply the rules carefully. But we've seen now that anti-differentiation requires, flashes of insight, right? Just cooking up the correct answer and then verifying that it's correct. Well, this seems, impossible to continue, right? How can we ever find antiderivatives if we just have to keep hoping for insight to appear? Well, the good news is that most of the rest of this course will be developing tools to make this kind of guessing more systematic, right? Instead of relying on just sheer insight to solve these problems, we're going to be providing tools that will aid your insight or aid your creativity, or provide a little bit of structure so that you can exploit the patterns that we're going to be seeing in order to find antiderivatives much more easily. So I think it seems hard right now, but it's going to get a lot easier.